Hey everybody, Lars here. Another day, another video. I actually decided I'm going to shoot this Euler video before I go over to HackRU because I might end up being there late and I might get home late and not be able to do the video, and tomorrow I have to be a judge, so nothing's going to happen there, and boom, boom, boom. And I want to get these videos out to you and get you as many resources as possible, so then you have time to sit with the assignments. You'll see that earlier today I released assignment number 1. So now you know about Harshed and you can get going on your Harshed function. I'll probably release the second assignment, the big enchilada, tomorrow evening. So you'll have that. So tomorrow evening, 12, 11 days before the end of the unit, you'll have your slides. You'll have a whole slew of videos to watch. You have the Zell readings. You'll have everything you need basically to put together that big program, which isn't that big. You're going to read from a file. You're going to process using a couple of functions that you're going to keep in a library, and then you're going to create some deliverables, 2 or 3 deliverables. You'll have to print out the sum of some lists, and you'll have to create an output file, and it's at the end of the day, it's not so bad, and it's very similar to the homework video that I shot last night, all right, so this is a quick hit. So without any further ado, we are going to look at a new version of Euler 6, and just to refamiliarize you with Euler 6, it was the one where the sum of the squares of the first 10 natural numbers was 385, square of the sum was 3025. You took the difference, so it was really 3 different problems, and then we got the answer. And when we did it, I actually brought the code up. You can see that we did it using our new tool at the time, which was iteration. So we just created a variable, and then we iterated through whatever the limit was and added up all the numbers we needed, and then we printed it out, okay? And then I just printed out the difference because I still had the variables at the end of the day. But when I see a problem like this, I see functions, because this is 3 different tasks, and if we take the 2 main tasks, the sum of the squares and the square of the sum, and we make functions out of them, then you could just have a regular program that in one line prints one call minus the other call, and you're done. And we could literally do this all in one line. Okay? So what I'm going to do is I'm going to create a library. And I'm going to create a library. Should I just use this one? You know what? I think I'm going to take a new tack here. I'm going to go File. I'm going to go Save As. And I'm in Fall 17. All right, you know what? I'm going to call this EulerLib. And it's already saved as a Python file. So now that is, and now I just have to say Euler library. My name is still Lars. We'll be leaving that. I don't need the description. I don't need that. All right. I'm not going to be needing this. Take this and put this down for that. All right. What if I wanted to turn this into a function? What would I do? I would say find the sum of the squares. I'd say def, and I'll call it sum of square. You can use that function name and still use these variables. Okay, the function name is almost at a different level from the inside of the memory variables inside. So you can use a function name that's the same as variables inside. Just a little bit of inside baseball. All right. And here, where I print, well, I'm not going to print anymore. I'm going to return the value. All right. If I'm not mistaken, that's it. All right, then what are we going to do? We're going to come up here. We're going to say def, and we're going to say SQOS limit. Bang. Done. I got me a library. Now, if I want, I could test in here, but I'm not even going to bother. File, new file. All right. I'm going to call it Euler with functions. And what am I going to do? I'm going to import Euler lib, and I'm going to print Euler lib dot SQ of 100. Now we'll do 10 because we'll do the worked example. And I'll make a copy of that. Copy, paste a new one, and I'll change this to SQOS, so we get the square of the sum and the sum of the square. And now when I go to save this, and I'll call this Euler W funcs, Euler with funcs. All right. So now when I run this, I get 385 and 32.5. So that looks very familiar. Okay. So what can I do now? I can say print. The difference is say A minus B. Now let's not say A minus B. Those are terrible variable names. We'll say sum square. Square sum minus sum square. And then up here, we'll do sum square. Now we could have just coded this directly. And here I'll do square of sum, assign the value of that. All right, now we're not printing it anymore. Now we run it. 2640. Look familiar? Oh no, I got to do it for 100. Look familiar. Not even ready. So then, yes, I know I'm changing it in 2 places and not 1. We should get a variable there. 251, 64, 150. Bingo. Okay. Now, I want to make some changes. We could take these calls and put them directly in here and do it all in one line. We can create a variable for that. We can even call it limit. Do that. How'd that happen? Something's going haywire. All right. So there's 4 lines. Okay? Because all of our logic is here in our library, where we have a function that does the sum of the square, and we have a function that does the square of the sum. And now that I have Euler lib sitting there, I never have to do that again. I just always have it at my beck and call. Okay? So that, to me, as a computer programmer, is a better way to tackle this problem. Because now that those tasks, codified, done, sitting in a library, they're ready to go. And then I import my library and use my library functions to get done what I need to get done. Okay? So this is, now that I have functions as part of my tool belt, then now I can compartmentalize things and put things in libraries and code things up. So the next time somebody has to write some code that needs the square of a sum or the sum of a square, they're sitting there to use. And you just know, what you would do is you'd write an API piece so that people would know about your code and people would know how to use your code. And then all they would do is import your library and go ahead and use your code. Okay? So this is Euler 6 done with functions. So now this is basically, this uses a lot of the stuff we've been going over. This uses iteration. This uses functions. This uses libraries. This is, putting everything we learn all together. Computer programming in the beginning is like mathematics in that it's a pyramid. You learn the basics, and that's your foundation. Then something goes on top of it. Then something goes on top. So you learn about the basics. Then you learn about if-then. Then you learn about iteration and sequences and how to iterate over sequences. Then you learn about functions. Then you learn about libraries. Okay? Next unit, we're going to learn about some computer science tricks and recursion and sorting and searching. But after that, we're going to go to the very next level, and we're going to learn about object orientation. And then you're going to learn about classes. And you're going to learn about putting data and functions together. And there we're going to call functions methods and do stuff like that, all right? All right, this was a quick hit. I'm going to get out of here. I'm going to take this code and I'm going to put it up on Sakai. So you'll have this Euler with funcs.py and the Euler lib. Download it, play around with it, make some changes. That's how we learn. Start thinking, if you can, in this way. When you get a problem and your homework assignment is perfect for something like this, you're not getting one problem. You're getting a series of problems that you have to break down, solve, and then put back together at the end. This is how we do it. All right? Libraries, functions, modularity, things along that line. All right, I'm getting out of here. I got to get to HackRU. I probably won't do the quiz video until during the week because the boys haven't graded it yet, so wait a couple days for that. Take a couple days without having to see my ugly mug and do some work and enjoy the weekend, and everything's going fine. Everything, knock wood, is going along great with this class, so we're in good shape. All right, you be good. I'll talk to you later. Bye.